Morning everyone, you're joining me from the college's state-of-the-art underground quarantined recording studio, so we'll continue our series of videos from here. I'm using a digital camera plugged into a laptop on this occasion. So we're going to be picking up a new topic today, the halogens part 2. So you'll want your green booklet for that, and things like a periodic table, and you're learning from the redox topic, so the blue booklet will be useful as well. You're going to be meeting a few elements and species like these for this topic. You need to be able to identify the oxidation state of all the atoms in things like this, so you can pause the video now and consider that to be your starter. So in order to do this effectively, we need to be able to do that very, very quickly. So we talked a lot about group 7, the chlorine, fluorine, bromine before. Now one of our teachers who used to work in the college, Kay, she used to like to introduce this with a poem. This is Dulce et Decorum Est, which is by Wilfred Owen. I'm only going to read you a short bit of it, but just to set things in context. This is a poem set in 1918 during the First World War, and it's about some soldiers. Dim through the misty panes and thick green light, chlorine gas is green by the way, as under a green sea, I saw him drowning in all my dreams before my helpless sight. He plunges at me, guttering, choking, drowning. It's a bit grim, but that is the effect of chlorine gas on the human body. If you breathe the stuff in, it will react with your lungs and form acids that will dissolve your lungs, and you will drown in your own blood. So the things we're talking about today haven't got a particularly good reputation. You know, the chemistry of the group 7 elements. In day-to-day life, we don't really like what we're hearing about. And that's due to the properties that you know of already, how well they lose and gain electrons. It's not chlorine's fault, if you ask me. You know, I think group 7's a bit misunderstood maybe because its chemistry is not very compatible with ours, but there we are. The result is the reactions that you need to know. Not necessarily that one about the damage to the lungs. The reactions we're going to be meeting are quite unpleasant to actually do, so we're not going to do them. We're going to show you some photos of them. Okay? So, the PowerPoint that I've given you to look at has got some pictures of what's going on in some of these reactions, but we'll come to that in a minute. So, Group 7 Part 2, we're going to combine what we know about redox with a few new reactions to explain some of these quite unpleasant looking reactions that these things do. So, we've had a go at that. Let's have a think about these elements when they oxidize and reduce things. So, the halogens, that's the molecules of group 7, exist obviously as dimers, as two atoms joined together, diatomic molecules. Diatomic molecules more than dimers, dimers being something slightly different. So you've got your two atoms covalently bonded together, and we're going to try and work out how good they are at acting as oxidizing agents. That means that if there's something else around, like this thing here, the oxidizing agent will cause that to lose electrons. So that electron will go up towards the fluorine. And if we compare that with the iodine, iodine of course is bigger. If you've got your periodic table handy, we're going down group 7, which is something we have done before. Hopefully you can see group 7 there. Down group 7 from fluorine to iodine at the moment. We've got the same thing happening over here. That electron wants to go towards this atom somewhere, and the bond between the two atoms would break. I haven't shown the electrons on the other part of the iodine or the fluorine. So it's the same sort of things as you've met before. How attracted is that electron to the positive nucleus? Well, it depends on how close it is to the outside of the atom. Okay, so this time we're talking about the attraction between the nucleus and the electron that's being lost from the other species. Okay, try and be clear with which attraction specifically you're talking about in this topic. That's come out of your key assessments quite a lot if you look at your key assessment feedback. So, I'm just going to check how we're doing for seeing this. Probably didn't see any of that at all, did we? I'll have a look in a moment. Might have to re-record. Yeah, let me have a look now.